Gotta wait till the recorder starts. We're going to start our process on looking at modules today, and we're going to walk through a couple of different things. I'm going to give you a challenge for Thursday to look at. A week from today, we're going to have an in-class quiz. That'll be actually, next Tuesday we'll be 25% through the class. So time flies when you're having fun or something like that. Tell me.
What is the quiz going to be about? Is it modules or?
It's going to be about Python.
Makes sense.
Okay? Don't worry about it.
Okay.
Don't worry about it. You'll be fine. Besides, the Illuminati's going to get you before you take the quiz. Helmy, I appreciate your good nature in all the classes we've shared together. All right. A couple things we're going to talk about before we jump into modules. And I do have a homework assignment for you, and I think there'll be time at the end of class for you to start on it. If we can get PowerPoint to not. There we go. I mentioned at the end of last week's lecture a little bit about a program called PIP. And I did some research and I found out apparently nobody else is teaching anything about it, including me in the fundamentals class, and I have since added a little appendix in the book for that, so that doesn't happen again. But let's talk a little bit about PIP. PIP, all lowercase, is the preferred install program for Python. And once I show you how to use it, it is so easy to use. You're supposed to say, how easy is it? Never mind. You all are too young for Johnny Carson. But it is so easy to use, it makes installation of packages very simple. And we're actually going to do it this morning with the program or a script module that we're going to use a little bit later, and we're going to do it from the command line so I can show you how that works. There are several different versions of PIP. Most of them are called just PIP, but for 3.5 they had a special version out, and it was called PIP 3.5. And now we're past that, so we're back to PIP. So you may see, if you go out online and look for it for some reason, you may see it with different numerical indicators after it. But I'll show you how to check and make sure that you have the correct version. Usually, you do it from a prompt to update something. And we do it at the command line prompt, as I said, so it makes it very, very easy. Now, take a look at this first before you jump into doing it, and we'll talk a little bit about it. Here's the line that has got PIP on it, and notice what we're doing. You can do it from any directory on your command line. So on these computers, like most, it should come up in your user area. It did on mine when I did this. And so all I have to do is type Python. It's not going to start Python up for you to actually see it, but it'll run Python in the background. We do a -M. I have no clue what that tells Python to do, but we use it with PIP. We'll find out. That could be 10-point extra credit if somebody looks that up and tells us on Thursday. PIP is the word we use, then we use install, and then we're going to install Pygame. Now, what do you look at this, and something should strike you immediately about that command line entry. Or maybe 2 or 3 lines down. I have not told...
Which Python is it?
No.
Pygame?
No. Which Pygame is it? I don't care. Notice what PIP does. PIP collects information about Pygame. It then goes out to the internet without us telling about it, and it finds out that the current Pygame for a Win32 install is 1.9.3. It's applicable to Python 3.5. 3.6 is in testing, it's not out yet. It'll download the package, it'll tell you how much it downloaded, it'll tell you the speed it downloaded it at, and then it will install the package for you. If there's a problem, it'll tell you, successfully installed Pygame 1.9.3. Great. The other thing that's cool about pip is it'll prompt you if you need to upgrade the pip program. So here we're using 8.1.1. There's a newer version available. You should download and use it. So I'm curious to find out whether or not you're allowed to add a program to your Python directory. So go ahead and bring up the command line, and you want to type in this line right here. Python space -m pip install Pygame. And let's see what happens.
It doesn't look like it.
Yeah, mine said.
Since that didn't work, we'll have to get William and Roy to upgrade you. What I wanted to show you next, though, is how easy it is to upgrade pip. And you can do this at home on your computers if you've got Python installed. Again, this is standard Python -m pip install, and then we do a / upgrade pip. And as you see, it'll go out. It's going to find the most current version. It's going to download it. It's going to install it. And I thought what was, this program, pip, doesn't take up much space on the computer, but yet it'll still go through and collect a package. It'll uninstall existing packages. Then it'll install the one that's coming down. So very, very useful program in Python. And if you start to get into things like facial recognition, barcode scanning, gaming, statistics, it can download and upgrade those modules for you very quickly. Colton?
For me, when I download it, it's already up to date. And then,
Really?
yeah.
Okay, you did pip? Or
Python -m pip install and upgrade pip, and so it's already up to date.
okay, so they installed it with the current version. Okay, interesting. It'll let pip go, but it won't.
Well, and I
Do
typed in
Pygame.
install game, it says couldn't find a version that satisfies the requirement game. So no matching distribution
Huh.
found for the game.
All right, I'll ask William and Roy about it. I promised I wouldn't mess with their computers too much. So, all right, but take this. The lecture will be out on D2L this afternoon. You can take this and upgrade your Python at home and work with it, and it'll give you up-to-date programs. The other thing, someone came and asked me from the fundamentals class, and I was just impressed, first of all, that they'd actually gone ahead and started PyCharm. But they said, what's this PyCache? What does that do, and why do we need it? By the way, here you can see that pip has been installed, and I ran this yesterday just to make sure everything was updated. Well, in PyCache, it's kind of a program that, or a folder that you'll find throughout the different projects that you do. And actually in there you'll find either PYC or PYO programs. And it's kind of a pre-compile state that Python does that allows you to execute your scripts a little bit faster. Now you can go into PyCharm and you can turn it off, or you can go in and delete it. But you'll notice as we get into bigger scripts, it'll sacrifice some of your performance time. So if you're wondering about what that is and why it keeps appearing and reappearing in your folders, That's what PyCache is. And it's interesting if you go through and look at some of the files that have been compiled, and as you update a file periodically, it'll actually recompile itself. The thing that fascinates me is that you can do some updates and it won't recompile, and you do other updates and it will. So obviously, like a lot of things in Python, it has a mind of its own. All right, any questions on pip or PyCache?
Just one more time. What is like just like the brief purpose of it? Like
The brief purpose of the cache folder?
Yes.
All right, Python will do a pre-compile function before it actually runs
Run
your
the
script.
Okay.
All right, and so that's to speed up the actual operation. So the first time you run a script, it'll do the pre-compile on it. The second time you run it, if you haven't made any changes, it'll go to this and run. One of the ways you can check it out, next time you write a script, go ahead and do the right click and run it from the code window. And then go back to the code window and make some changes. But instead of running it from the code window, go to the results window and click the execute icon. And you'll find out that it ran the old code, which it's picking up from here. So actually, PyCharm, if you want to run the code that you haven't updated, will actually allow you to do that for a while until you compile that new code, and then it'll update the pre-compile. Good question. Anybody else? Okay, let's talk a little bit about module libraries. Modules are in libraries, and they can stand alone. So we could make a set of modules, and they could stand alone in a directory, in a project, in a unique folder. And I'll show you how I have mine set up as an example. And they're standalone or in a library as opposed to functions that actually live in our script or our program. And we talked about those last week. Now, along with our standard module library, and there are probably 100 or so different modules that are in that library. If you're interested about them, you can look in, I think it's Appendix E in the textbook, or you can go out online to python.org and look at the module documentation. It's pretty consistent over versions 2.7.2 through what we're currently using. Prior to that, some of the modules that we're using now were not there. And the random number module, as an example, has been updated and changed. So it's not cross-platform compatible. But that standalone library, again, is delivered with Python when you download it, and will be installed when you do the install for Python. The standard library has nothing to do with PyCharm. PyCharm uses it because it's using Python. Okay, and last semester the scripting class kind of got that confused a little bit. Shortly after they had that lecture, if you get my drift. There are different libraries that we can use also. Cartography is one, mapping, where we can get into a variety of different maps and not necessarily geographic, facial mapping, barcodes, so on. There are a lot of different libraries that we can download for that. By the way, you'll find out the libraries, by and large, are free. But if they are really doing something specific and something unique, and somebody thinks they can make a couple of bucks off of you, they're going to charge you for that library. My experience has been, at least with Python, I can find something very, very similar, if not exactly the same, as a free download somewhere. And it'll do pretty much the same function. Gaming. There are a lot of game modules. In fact, when you download Pygame, we get into some additional modules that we can look at, and some examples are cameras, a little more extensive mapping that would relate to a game map that we look at, some character design functions, several different things that we can use. At the end of the semester, if things go well, we'll get into Pygame and we'll make a couple of games and see how we do with it. So, cartography and gaming are two of the libraries that you can add. You can also add a database library, and we're going to look at that when I think it's when we get to chapter 10, and we'll actually use some of the built-in database modules that are in Python. In fact, they are extensive enough that you can actually run what we call an Oracle instance from a Python program and add tables. This may not mean a lot, much right now, but we can add tables, we can modify attributes, we can add entity instances. If you haven't had the database class, take it, then we'll talk about what all those are. But Python can run Oracle, which is pretty impressive. It'll also do a halfway decent job on SQL Server and MySQL, although MySQL is owned by Oracle now, so we might as well just call it Oracle. There's also a GPS function. They call it in Python GIS. Nobody knows why, they just do. But if you want to tie in a Bluetooth GPS function to Python, you can do that. One of the ones I don't have on the slide is Bluetooth, and I noticed the other, over the weekend. During the Super Bowl, when I thought that Atlanta was going to win, and I was bored, they've got a new Bluetooth library out for Python now. And you can download that and connect your cell phone, your wireless keyboard, whatever, to Python. But we've got a GPS function. We also have several foreign functions. I'll get to you in a second, help me. We also have several foreign function interfaces, and those include language interfaces and the ability to translate languages. And they're pretty extensive, although some of these I noticed people want bucks for. And then one that you'll be interested in and we'll use shortly after we come back from spring break, the networking library. And we'll do some things with the command line and some short networking programs that might help you in the future if you're going on into cyber. One of the challenges, although Python is extremely useful in cyber, if you know much about what may go on in cyber, you may only have 30 seconds, maybe 2 or 3 minutes at somebody's machine if you're trying to get into it. So you're not going to be able to download a 400 or 500 line script and try and run it. So what we'll show you is command line things that you may find useful, or programs that you can memorize 2 or 3 lines long that you can run and get information back from them. And that'll come up probably sometime in mid-April would be my guess. Helmy, question?
About the Bluetooth thing now, but I didn't, if you're, you make a script that makes a connection, or, I didn't get the idea of the...
Okay, the idea behind any of these, all right, in Python, is that if I have a Bluetooth module, that means that someone has already figured out the hooks to go to the Bluetooth service on your laptop, for an example, and bring those hooks into Python, and there is a way to talk from Python to that Bluetooth interface. Now, what you do with it is totally up to you. As an example, right now we're looking over at the Digital Prototyping Lab at the GPS interface. we're working on building quadcopters. And we can do everything, the electronics, and now we want to do the programming. So looking at Python, and since we teach Python, we're looking at how would that GPS library interface with any quadcopters that we build. So it's kind of like that. Yeah, the GPS link is there, and I know whatever, let's say there are 4 things that we can translate to and from GPS on a quadcopter, X, Y, and Z axis and speed. I know that in Python there'll be a hook so I can send that out to a GPS receiver. But I've got to program how I'm going to do that and how I'm going to control it when it comes back. So you stay in this business, you get to learn a lot of things. Any other good another good question? Any other? Okay, my library is pretty simple. I'll show you how it works here in a minute. What I am showing you is just a sample library. The one that my working library is over on my computer in the digital lab. I want you to experiment with this, and we're going to talk about you building your own library here in a little bit. But experiment and try. I'll show you how to create a library where you can put all your functions in, but again, you can also create a standalone module, and we'll look at how we do that on Thursday. All right, when you're using your own library for classwork, and I have no problem with you doing that with a couple of caveats. First of all, your code's not going to run if I don't have your library. So drop your library into any assignment that you put into the Dropbox. We'll make it easy, score of 0 if your code doesn't run because of the library. Don't let that deter you either. Go ahead and create a library. The more comfortable you get with it now, the more it's going to be useful for you in the future. You're probably sick of hearing about FAA, but when I was at FAA, we tried to develop C# libraries. Drove us nuts. But this is a piece of cake. Very easy to create with. Also, I'm going to show you how to create a description with your module. And this is one of the things I'm going to test on the libraries that you're going to turn in for an assignment. And within Python, if I'm not sure what a module in a library does, I can actually go in and write the code to pull out the description of that library. In fact, it can get extensive enough. As an example, I can't remember, I think I'm showing you the one on random numbers here in a couple of minutes. It can get extensive enough to suggest how you might use that module. Again, all of it is based on the effort that the person that developed the module wants to put into it. So mine lives in my Python program folder, and it's called My Library. Very creative, but that way, so far I haven't downloaded any other libraries that are called My Library, so it makes a lot of sense, and it's right there. And you can see for the example in class, I've put together 3 different modules: a clear screen, a file operations, and a test script that prints hello. Big deal. And of course we got the PyCache, and then this test file is associated with the file ops that allow me to test communication out to whatever I'm looking at. Here is the print hello, and you'll notice I set it up this way to begin with. Up to this point, we've used the single quotation marks and an asterisk, and then a description of our code. And that works extremely well for us, and I can look at your code, or you can look at your code, and tell what it's going to do. But this we can't access from outside of being in that code block. An end user couldn't pull up information about it. And I'll show you how we do that in a second. So this is the module, very simple, define, print hello, run, the print, it's going to print hello and it's going to return. All right. So this could be written as a standalone program. You could call it anything you wanted to call that program, but it would, the actual code would start with define print hello, and that's how you would refer to it if you were doing any coding. Now, lines 11 and 12 are something that you're going to find useful, at least at home or on a laptop. I'm not sure you're going to be able to use it here in the lab. And what lines 11 and 12 do is they check in your system path folder to see if your library is there. And if it's not there, then line 12 comes through and appends your library location to that system path. So when I run this code with any of the modules that I run, it'll immediately point to the path on my office machine where my library lives. 2 lines of code are absolutely worthless here in the lab. All right, but when I'm running on my machine in the office, it works fine. Now, there's a way that you could go through and write this so it could check on whatever computer we're looking on. The problem is it's not going to allow you to modify the system path anyway. So if you're interested, let me know and we'll put that out there. Also notice, in this case, I'm doing an import system. And then I'm importing from my library print hello, and that import system just ensures that if there are any operating system files that I need when I'm running this module, they'll be there. Also notice line 1, and I think I talked about this once before. Again, it's just a tip. We use a comment, the boom sign or exclamation point, Python 3. And what this tells any interpreter that runs our Python program, use version 3.x of Python to operate this code. So if 2 is on 272 or 277 is on your machine, it would look at that first line and stop the script. Okay, so it's a good thing for you to look at. Another thing you'll find out is that even though my library and print hello exists, Python is still going to look at them and show them to you as being underlined in red. It doesn't think they exist. All right, and that clears up when the program runs. All right, and then finally the print hello.
What's the boom before Python 3?
That means check to see that version 3 is available on this computer. If it's not, don't run this script.
So it's actually talking to
It's actually in line 1 actually talks to the interpreter and says, "Who are you?" And if you're not Python 3.x, I don't want to talk to you, and it'll stop the script. Okay, good question. Anything else? I don't know why we've got this one again. Oh, I guess just to talk about, don't panic if you see red lines under your library and your import. By the way, line 14, we can do 2 different things. I could just say import my library, and it would import every module that's in that library. This library only had 3 modules, so not bad. But if I had something like the game library that has maybe 100 different modules in there, it would import all 100 modules. at once, even though maybe all I was going to use is one or two. You do that enough, and it's going to start to affect your execution and time. So there's what the library name is. There's the import statement. Oh, and this is just execution, and again, printing it out down at the bottom. Very easy to do. All right, well-designed modules. Let's talk about this. They should be accessible from anywhere. So if you have a specific project that you're writing a library for, but it's only going to be used in that project, then that's the only place that library has to live. If you're writing a project or if you're writing a library that you want to use on any machine that you're working on, then it may be a library that you want to carry along with you and have it be accessed by a specific drive that's out there. I got the feeling I don't have all the back row with me. Your module should be able to tell you something about itself or tell you how to use it. And we'll look at that on the next slide that's coming up. And it should provide some help if there are any sticky issues in that module, any problems that you think the end user might encounter. Head them off and tell the end user about those problems as they come up. And you'll see it's very easy to bring up that help file. Here we are. I've gone into Python, and I've got Python. There's our Python prompt. And what I'm going to do is I'm going to import random. Now, you have to do an import statement before any of this works. I can say just import random because random is a library module that's delivered and installed with the standard Python library. And now I can say dir random. Question?
No. What is dir?
dir is directory of the
Directory, okay.
Yeah. And these commands go all the way back to CP/M machines in the late 70s. And that's one thing, little footnote for you. Any computer that's running today still has the roots of the CP/M computer programming that started back in the 70s. So I can go into a command line prompt and type in dir, and I can bring up the current directory that the computer's in. I can also navigate through that directory. If we have time at the end of class, I'll show you how it works. But they're kind of good. People don't pay attention to those types of commands anymore, and if you're going to start be a white hat hacker and get into cybersecurity, you probably want to learn some of those. So, used in Python, when I type dir for random, it will give me a directory of everything that random can do. And some of them you'll see examples. Here's random integer as an example, random range, a seed number to start your random generation with. All of these are things that you can read about and take a look at. Now, this is a directory of everything we can do. Let's say we need some more information. Well, I've already imported random. I can just type help random. And when I do that, I start to get pages and pages of information about that module. Now, the one caveat with this is assuming the programmer who created the module put the information into the script. All right, so here's random. Quick definition generates random variables. The description, we can get integers, sequences, distributions, and I guess I didn't print out another page. But this goes on for like 10 or 12 different pages. All right, so it's very useful in helping your end users find out what the module can do and how it can be used. Do I expect you to do this in the libraries you write? Well, at least put a description in, and I'll show you how to do that, but you don't have to go the entire way. And by the way, if you take a contract as a programmer and they don't ask you for that, program it in for your own use and make them pay for it if they want it. And actually not having a contract that covers help files, I've seen put contractors out of business because they'll roll over and say, oh, all right, we'll give you the help file. If you didn't write help files as you created the program, you're going to burn up a lot of money trying to create a help file that the end user or the person that's signing your contract or you had the contract with will want to use. And
as long as I get my money, I'm okay.
Yeah, as long as you get your money. Yeah. In fact, sometimes writing the help files is more expensive than writing the code if it's done right. Some things for you to think about. Where are you going to keep your module, your library module? Your options here are, we know you can't write to the computer directory. You can write to a Google Drive, but we can't set up a Windows option on these computers. You can always write to a thumb drive or a portable hard drive, and chances are you can set the identifier so that will always be the same location, same drive letter location on your computer. So you can look at that. I guess if you got really creative and you're a masochist, you can create a CD with it on or a DVD with it on. On campus, on 99.8% of the drives, the DVD player is drive D. However, there are computers on campus where it's not drive D for some reason. Word to the wise. What's it going to contain? Well, what would be useful to you right now in script programming to have on in a library? Well, maybe file operations. Read, write, append, delete if you want to do that. Be careful with that one. But some things to think about. How will you maintain your library? And this is a good one because as we go further into the semester, you may want to make some changes in your library, especially when we get into looking at classes and how we handle database operations in Python. So how are you going to maintain it? What's the easiest way to do it? Putting it on a CD or a DVD may not be the easiest way to do it. There are a couple of different standard programmer techniques that you can use. One is called version control, where every time you make a change, you either make it a big version number change or a dot version number change. And the rule of thumb that we used to use over at Tinker was if you add to or change more than 50% of the code that you're writing, then it's a new version number. So in my library, if I added 6 more modules to my library, then it'd be version 2.0. All right, kind of arbitrary. You can use, you kind of use Kentucky windage to see what you want to change it with. PyCharm change history is another way, but that change history can go away. And we talked about last week that change history is not available if you jump from computer to computer. So it's one thing that you need to consider when you're doing that. Mercurial is a software version tracking program that you can download. It'll help you track on version control. By and large, it's a free piece of software, but it's going to take some overhead to install, and you're going to have to learn how to use it. But probably at your point in programming, the arbitrary version control is probably the best way to look at it. And of course, you can compare with the PyCharm local history on what you have and where you're going with it. Every place that I've had a job where I had to program, we used a program from Microsoft called Foundation Server. Expensive program, an installation to handle, as an example, FAA, where we had, we had 10 government programmers and 15 contractors programming. It cost them 50 grand to set up Foundation Server for our operation that we were using. And once it was set up, then you had to religiously use it. In fact, there's a way to set it up. If somebody checks out the code and doesn't check it back in, then everybody gets an email that says, Helmy checked the code out, didn't check it back in at the end of the day. And what happens is you check the code out, it will track your changes, and then you're prompted when you check your code back into the code library, what changes did you make on that day? And we actually had an administrative assistant, didn't know anything about coding, but she knew enough to go through and check all of the code and find out what was checked out, what had been checked in, and anything that was that had been checked out in the day, was there an update as to what the functions did with the code. So when you get into the bigger contracts, people get very serious about tracking what you're doing with your code. Yeah, we're just a sophomore programming class using Python. But if you get in the habit of doing it now, it's going to be a whole lot easier. All right. I've told you, I took my first computer class in 1968. And I remember Dr. Lewis standing over us saying, you guys aren't going to get to go to the student union and have beer until you finish documenting whatever it was that you were trying to write for my class. It doesn't make any sense anyway. He was a real interesting guy. But if you start now and make it second nature, it's going to work. And I know half of you, it's going to go in one ear, gain speed, and out the other. 10 years from now, you're going to say, why the heck didn't I listen when he said start documenting? All right. I told you that we could go through and read information from each of the modules that we wrote, and this is how you do that. We put in 3 double quote marks immediately after we define what our module is. And so description prints a cheerful hello to the end user, and then we put the code down like that. So it's 3 double quote marks at the beginning, 3 double quote marks at the end. You call that out, just like we did when we looked at random. We set the library up and we pulled out our hello print. We've imported it into our script. So if we want the information, we do print help and print hello. And when we do that, this is what the results window gives us. Help function, print hello. Description prints a cheerful hello to the end user. And then if we wanted to go further and add additional inputs, maybe limit what they were able to input to use that module, we could do that. You saw how extensive the one got with the random numbers generator. So I'd recommend that you do something like that. Again, it's very, very simple to use. 3 double quote marks at the beginning, at the end. Python culture says use description. Those of you that are anti-establishment probably won't, but as long as I can read it, that's good. And then, of course, anything under here that we might want to tell the end user, you're limited to using only character strings, or you're limited in this module to only using integers. You'd also add that underneath in any format that you wanted to use it in. What kind of modules might you use in a library?